This section of the course is all about PLC sequencing. So now that we have our managers in place, our data for our assets in place, we have control layers and interlock layers and everything that we need to tell a program what it needs to do. This is the first step in actually programming our sequences and having responses to data that we have coming in for our assets. So what we can see on the screen here is a typical setup for how I individually would set up a sequence. But it does give a good viewpoint into how data is being managed in sequence design. So what we can see here is I have a filtration sequence start and shutdown manager. And what this block is doing here is controlling whether a sequence should be starting and also whether a sequence should be shutting down from an external point of view. So commands from SCADA to say a button's been pressed to start the sequence would be managed by this block, but also a valve failing that is crucial to the sequence control is also managed in this block. And again, it's following the convention of trying to break everything down into singular Boolean values or values of some sort that can be passed to the sequence manager in order to tell it what to do. So we might have a few 20 odd different signals that come into this block here, but they always come out as you're okay to start, you need to shut down normally, or you need to shut down because of a fault. And then what we have over here is the filter sequence manager itself, which is actually managing the filter. And the thing that's common between both of these blocks is that they accept data structures, the same as everything else so far in this course has demonstrated that we are using UDTs and structures to facilitate passing signals between our systems. And this sort of setup is no different. In the start and shutdown manager, we're passing all of the filter data and all of the filter interlocks. That's everything that comes from SCADA, and that's everything that comes from internally created interlocks. And you'll find that we also pass those into our sequence manager as well. So on the front of the sequence manager, we have our start sequence, which is mapped to the OK to start. We have a fault shutdown required, which is mapped to our fault shutdown required. And we have a normal shutdown required, which is mapped to our normal shutdown required. They do come on in the interlocks layer as well, because they're being written to in the interlocks layer, but I do like to put them on the front of the interface just in case, for whatever reason, if you're using this sequence and later on you need to make a modification that causes a fault shutdown, you're free to add new contacts in without having to reinitialize this block because you're changing the interlock layer. And things like that will become apparent the more you use this type of setup. But sometimes, even if something appears in a structure that's being passed to your block, putting it on the interface has some flexibility bonuses. We then have the failed to fill, filtration system failed. Those alarms coming in on the front for the integer for the lookup, which we've been through how we're doing that alarming. So that should make sense to you. And then I've said about the structures coming in. And then what we have is the entire assets that are used in the sequence themselves being passed in. So IL01, which is our level sensor and its bespoke structure. And then we have AV01 for the inlet valve, the filter outlet valve MV02, and our alarm group and alarm management function, or structure rather. And then on the output side, all that we have is AV01 open command and MV02 open command, because those are the only two components that make up the filtration sequence. All we're doing is opening the inlet valve to let water in, and we're opening the outlet valve to let water out. That doesn't mean that it's a simple control system, because we still need to maintain a flow set point, and we still need to monitor turbidity and level control and all that sort of stuff. But we don't need to have the sequence control that. The sequence just needs to enable those devices, the two valves, to do what they need to do. And then we can pick up from the actions passed to those valves that we need to enable other controls that sit around the sequence and then ultimately feed back into the shutdown manager to say something's gone wrong, I need to shut down. Before we finish this lesson, if we just jump in and have a look at the filter sequence manager, we can see areas that we interact with from the outside of through the interface. So this is the normal shutdown required, fault shutdown required, and it sets internal control statuses to say I'm shutting down or I need to shut down due to fault. And then we have the actual sequence itself. But something that I wanted to touch on was we also have an internal fault shutdown sequence, and that sequence interrupts the main sequence and causes the shutdown. Now, the advantage of doing things this way, and we will cover this in the managing sequence shutdown section, the main advantage of doing this is that should you start a sequence shutdown where that is interruptible as well. So there are times where you might have sequence A and then that's told to shut down, but the shutdown can be interrupted by the fact that a condition has become healthy again. You don't actually have to stop your main sequence in order to run this shutdown sequence. And only when the shutdown sequence is complete do we then tell the main sequence, I've shut you down. And this will become more apparent again as we go through managing the sequence shutdown section and sequence output request section. And we'll see how these nested sequences can interact with each other, and the fact that you can nest as many as you need to nest within limits to achieve what you need to do. So that means that our sequences comprise of three main areas to do with sequence control, which is this main area here, filter sequence manager. We have the sequence start and stop requests from outside of the sequence. That's where our main program controls the sequence starting and stopping, which is this block here. And then we also have back in the sequence itself, we have the internal shutdown sequence control, which manages the actual shutdown of the sequence in a safe way. And then just sat outside that, we have our request handler, which is actually facilitating the request to the valves or whatever assets are part of this sequence. And what that's doing is ensuring that whether you're running the main sequence, a shutdown sequence, some other intermediate sequence that interrupts, that all of the requests that are raised by all of these different levels are all handled correctly, and only one open command or close command, or whichever way you need to do it for the asset you're controlling, only one command is ever sent to the asset at any one time. And again, building that sort of stuff into your asset-orientated design is crucial to being able to operate it with flexibility and modify it later without causing issues to other areas of code. But as we go through this section, we'll see more of this, and we'll see it in different languages as well, and we'll understand a little bit more about how all these puzzle pieces come together.